Hello and good evening again. I know I said that I wanted to make less videos about Flerfs, but this last video I watched from Brian is just pure gold, and I didn't want to miss out. So this is my take on Brian's latest failure on Polaris, and I thought we're gonna have a little fun and we're gonna play Flerf-Olympics 2022. And the first contest will be in missing the point. So, in this first discipline, Brian totally knocks it out of the park. So, in this part of his video, he's quoting astronomy.com, I think it is, and he's talking about how Polaris apparent height decreases when you go further south, so from the North Pole towards the equator. And the point he's trying to make is totally ludicrous. He's trying to explain how that height at the equator would still totally work on a flat Earth. Doesn't matter, it's just word salad. But the way he tries to explain how what is actually said in the text here is just awesome, because he doesn't even get how they come to this 0.66 degrees. So at the equator, Polaris would be visible at 0.66 degrees without atmosphere, because the Polaris doesn't sit directly at the Earth's North Pole. It's a little shifted, and they explain this in the text here. And Brian doesn't even get that. He wonders in the video how they arrive at this 0.66. And Brian, newsflash, it's right there. 90 degrees is the true North Pole. Polaris is actually at 89.34 degrees. Bam! Brian, it's not that hard. Okay, that was the first discipline. I think Brian did great on that. He didn't even break a sweat. So we're gonna go to the next one, just making stuff up, because as you can see, he doesn't even understand how anything works. So he just continues on digging himself deeper into whatever this is going to be. So in this part of the video, he shows this diagram, and he doesn't even explain the diagram on the left here, although this is pretty interesting. We're gonna get to this in a sec. He babbles on about this left side, and he shifts this around, and he claims that this is the so-called free space of Polaris. So the further you move towards the equator, the more Polaris sinks. And so the bottom part of his rectangle is supposed to be the horizon, I suppose, and the top part is supposed to be the height of Polaris. And so the further you get down, or towards the equator rather, this free space shrinks. So he's basically talking about the angle that Polaris has from wherever on Earth we look at it, but he calls this free space. And I think he does this because he has no other way of explaining what's going on in his freaky world. Because, and now we get to this diagram, again, he doesn't really explain why he's showing this. He's not really explaining any of this, but the side view of a person or different persons on a flat plane would look at Polaris just doesn't make any sense. And it's right here. The distances and the viewing angles do not match reality. We have 69 nautical miles per degree all around the globe, from the pole to the equator to the other pole. I think Brian landed this perfectly, although he fumbled a little bit in the middle here. The next discipline. In this part of the video, he tries to rationalize his BS about his rectangle, his polaris, free space stuff. And he tries to explain this 0.66 degree from the very beginning of the video, if you remember. So the way he makes this up is just amazing. He has his triangle calculator here, and he types in the distance 5,400 nautical miles, because that's the distance from the pole to the equator. And he just makes up a value for the size, which is the size or the height of his free space. So in his model, this is the height that Polaris is above the Earth, and he has to put in 63 nautical miles here to get at this 0.66 degrees, which is just, I'm lost for words here. Just really, it's not just because English is my second language, it's just because my brain cannot even comprehend what's going on in what's left of his brain. Yeah, so that's his free space stuff, and he actually thinks that this is the height of Polaris. Okay, this is bad enough as it is, but he's actually going a step further, and I think he's doing this deliberately. Okay, so you see this screenshot here. This is the screen that we see in his video of this website. If you actually go to this website, it looks like this. So we saw in his video, we saw this portion of this website, and he punched in his distance and his size value to get this. If you actually look at the diagram that's shown up here, how this calculator down there actually works, you see that this is the size of the triangle, right? This is his 63 nautical miles. This is his distance, 5,400 nautical miles. So this whole thing is his angle, 0.66 degrees, which doesn't make sense, because they are banging on about how we have to have a non-curved adjacent and a right angle in our triangle to even do navigation with a sextant and stuff. That's all they're on about all the time. This is the height, you idiot. Let's help this guy a little bit over the finish line. So we have his calculator that he's using. We punch in his 5,400 nautical miles just for the heck of it. And now we calculate the actual angle that he claims we have to measure for Polaris. So we just double whatever he came up with, because we have to have the degrees at the end of that calculation. So we arrive at 1.33 degrees. We have that. He gets his 0.66 degrees. The interesting thing is why his BS idea that Polaris is 126 miles above the Earth should be apparent if you think a little further and actually punch in a few other distances and check if they make sense. So let's check, just for the heck of it, my rough distance to the North Pole. I would have to look at 1.45 degrees above the horizon. That's where Polaris would be, if that would bear any truth, what he came up with. If we were to go to Dublin, for example, think it's around that distance, it would still be only just above 1.5 degrees above the horizon. And if we go further, if we go 1,000 nautical miles, it's only 3.5 degrees. 500 nautical miles, 14 degrees. Now we're getting somewhere, because now the distances match or come closer together, and that's why the angle rises here. That's roughly the angle that I have to set on my telescope mount to align my scope with Polaris. I do not live 70 nautical miles from the North Pole. Brian, I'm sorry. You're just full of crap. But I still have to hand it to you, Brian. You really knocked it out of the park. You are the first winner of this year's Flerf-Olympics. We might have taken some damage on the way. This has been fun, guys. I wish you all a good night or good morning wherever you are. Take care and see you soon. Bye bye.